So our next example is going to be example 2. And example 2 is here to demonstrate the idea that these logarithmic and exponential equations that we've been talking about allow us to solve application problems. So as you look at the words in example 2, you're going to see that this p of t function represents the population of the United States. And t is going to be talking about a particular year. So you plug in a year of t and you can find the population that goes with that. However, as you continue reading, this problem actually says, we're going to give you the population and we want you to find the corresponding year. So they've given us a population of 354 million. Now, you have to make sure that you read through these words very closely to notice that they're telling you that this p is measured in millions. So we don't have to worry about putting 3, 5, 4, and then put a whole bunch of zeros after that, because p of t already is using those million ideas. So p of t is simply going to be 354, and then we're going to have that right-hand side. It's 304 times 1.009 to the t minus 2008 power. So now that we have this, then, our goal is to solve for t. This is an exponential equation. So thinking about some of the things we've been talking about, one of the first things that I notice here is that on the right-hand side, I don't have just my exponential expression. So I want to isolate my exponential expression. So to isolate, I need to divide both sides by 304. So I have 354 divided by 304, and that's going to equal 1.009 to the t minus 2008 power. So now I have a number on the left-hand side and an exponential expression on the right-hand side. So one way that I could move forward on this problem is to go ahead and talk about log base 1.009 of both sides. However, log base 1.009 is not necessarily easy to play with, so I'm going to go ahead and steal an idea from our previous example, and I'm going to introduce the idea of saying, in order to bring this piece right here, the t, down from the place where it's inaccessible right now in the exponent world, down to a place where it's accessible, let's just take the log of both sides. And again, in order to take the log of both sides, you can choose whichever log you feel like. I'm going to do natural log. So I'm going to take the natural log of the left-hand side, get the natural log of 354 divided by 304, and natural log of the right-hand side, natural log of 1.009 to the t minus 2008 power. Now that I have that, then, remember once again that if you have the natural log of somebody to a power, you can bring that power down in front. So let's go ahead and see what happens when I do that. So if I bring that power down in front, left-hand side isn't going to change. Right-hand side, the only thing I have to be kind of careful about is to make sure that I enclose that exponent in parentheses when I bring it down in front. So it's going to be t minus 2008 times the natural log of 1.009. Now, once again, at this point, there are lots of different ways that I can move forward. So my goal here is to get that t alone. So one thing that I could do at this point is distribute the natural log of 1.009 through to both terms on the right-hand side. I could do that. However, I'm also noticing something else that I could do. Notice this whole set of expressions on this set of parentheses is connected to the natural log by multiplication. I can go ahead and divide both sides by the natural log of 1.009, and that's going to at least get the t more alone. So that's what I'm going to do. Not the only way we could move forward, but it's one way. So we have natural log over on the left-hand side, and I'm going to divide that by the natural log of 1.009, and that's equal to t minus 2008. So now I said that my t is more alone, but it's not fully alone. So in order to get that t completely alone, I need to add 2008 to both sides. So my t is going to be then 2008 plus this big old fraction, natural log of 354 divided by 304, all divided by the natural log of 1.009. Now, at this point, I have an exact answer. However, this exact answer is not helpful. Because if I was wondering what year this population was happening in, I really can't tell from this particular version of the answer. Is this 2020 or is this 4004? So what I now need to do is, because this is an application problem, go to my calculator and find a decimal approximation for that second term, add that to 2008, and then I would have an idea of what's happening on this one. So what I want you to do, go ahead and pull out your calculator, find the natural log of 354 divided by 304. Once you have that, divide that by the natural log of 1.009. Take that answer and add it to 2008. If you do that, then you should find that you have an answer of 2024 and then a whole bunch of digits after that. So 2024.9, and then it keeps on going. But in terms of figuring out what year this is happening in, it's nice to go ahead and just round to the nearest year. So if we round to the nearest year, we would say 2025. So the answer to this particular problem, to the nearest year, is that we're going to have a population of about 354 million in the year 2025. At this point, you're ready to go ahead and check out the homework for section 6.6. Have fun.